So this is what we actually came here for. We want to talk about doing geometric transformations with matrices in order to do reflections, rotations, dilations. And for all of these things, we're going to use the same basic technique. We're going to ask ourselves, where does 1, 0 end up and where does 0, 1 end up? That's going to help us build our transformation matrix. First, reflections. A reflection is some kind of transformation in which you reflect something over a line. Now, that line might be horizontal or vertical. That line could be at any angle at all. Now, it turns out for a linear transformation, the reflection line has to go through the origin. If you're trying to do some transformation that involves reflection around a line that goes somewhere else, not through the origin, then you have to do a translation, do the reflection, and then translate back. So all the lines of reflection we're going to use are going to be going through the origin. Now, this also talks about something called an invariant line. I'm going to come back to that idea later. What they're saying is, along the line of reflection, these points don't move. If I'm reflecting across the x-axis here, then these points on the x-axis don't move anywhere. They're reflected to the same point. But everything on one side gets reflected to the other side. So, okay, let's think about this reflection in the x-axis. What happens to the point 1, 0? Well, it's not going to move, is it? So the first column of my matrix is going to be 1, 0. And what's going to happen to this point 0, 1? Or this one here if you prefer, 0, 1? Well, it's going to reflect across the x-axis down to -1. That's why this is 0, -1. So that's the matrix for reflection across the x-axis. Okay, what about the y-axis? Well, same method. What happens to 1, 0? If I'm reflecting across the y-axis, 1, 0 is going to end up at -1, 0. And what's going to happen to the point 0, 1? Well, it's actually on the reflection line, the invariant line if you prefer. It's on the reflection line, so it's not moving, it's staying at 0, 1. So this is the matrix for reflection in the y-axis. Okay, what about the line y equals x? And you're just going to ask yourself the same question. What happens to 1, 0? Oh, it's going to reflect directly across to 0, 1. What about the point 0, 1 is going to reflect to 1, 0. So again, I can easily work out the reflection matrix like this. And we could go on. What's the matrix for y equals -x? That's the line that goes like this. And we could keep going like this. The point is not that you need to remember every single matrix that there could be for every possible kind of reflection. The point is, given the context, can I work it out? And each time you ask yourself, where does 1, 0 go? Where does 0, 1 go?